Okay, if you're writing in Go, you're using strings. It's just a fact. But do you really get how they work under the hood? Nailing the details of Go strings is, seriously, one of the fastest ways to impress in a technical interview. So today, we're going to break it all down, from the basic bugs that trip up everyone at first, to the sneaky performance traps that only senior engineers know to look out for. Let's dive in.
All right, let's kick things off with a little pop quiz. Take a look at this string, go she. My question for you is simple. What is its length? Now, if your brain immediately said 4, because, there are 4 characters, well, you're about to see why Go strings are so tricky. The answer is 6. Yeah, 6, not 4. And you're probably asking, why? It's because the len function in Go doesn't count characters, it counts bytes. And that last character, si, actually takes up 3 whole bytes to represent. This right here, this is the core misunderstanding we are going to clear up for good. And that brings us to what I call the great string illusion. See, we think in characters, but Go thinks in bytes. And to really get good with strings, you have to see them the way Go does. That means we need to understand what a string, a rune, and a byte really are. So let's start with the official definition. In Go, a string is a read-only, immutable sequence of bytes. Now, there are 2 words there that are absolutely critical. First is immutable, which just means that once you create a string, you can't change it. And the second, even more important word, is bytes. That's the raw stuff strings are made of, not characters. Okay, so if a string is just a bunch of bytes, where do our characters come in? Well, that's where the rune enters the picture. A rune is just Go's special term for what you and I would call a character. Under the hood, it's just a number, an int32 to be exact, that represents a single Unicode code point. Think of it as a universal ID number for every single character, symbol, or emoji out there. And finally, we have the humble byte. It's really simple. It's just a number between 0 and 255. This is the bedrock, the fundamental building block. Every string in Go, no matter how complicated it looks, is just a collection of these little guys. So how do all these pieces fit together? I find an analogy helps a lot. Think of a string as an entire book. The individual bytes are like the letters printed on the page, A, B, C, and so on. But a rune is more like a sound. The language the book is written in, that's UTF-8. And in that language, some sounds need multiple letters to be written down. That's exactly why one rune, like our sh character, can be made up of multiple bytes. All right, so that's the theory. But how does this whole byte versus character thing actually mess with our code? Well, the number one place developers get bitten by this is when they try to loop through a string. Let's look at the right way to do it, and, oh yeah, the very, very wrong way. The right way, the safe way, the way you should always do it in Go, is with a for-range loop. This loop is special, it's smart, it doesn't just go byte by byte, it actually understands UTF-8 and decodes one complete rune at a time, no matter how many bytes it takes. It's totally character safe. And check this out. This example shows you exactly why it's so great. Look at the code and then look at the output. The loop gives us the index and the rune, but pay close attention to that index. It goes 0, 1, 2, and then it jumps straight to 3 for the she character. The loop knew that G, O, and dash were 1 byte each, and it correctly decoded all 3 bytes that make up she as a single unit. It just works. Now, for the dangerous way. The classic for loop, where you go from I equals 0 to len s. This loop is, well, kinda dumb. It has no idea what a rune is. It just plods along, 1 byte at a time. Now, if you're only dealing with basic English text, you might get lucky. But with anything else, it's a recipe for disaster. And here is the proof. Same exact string, but with the wrong loop, and the output is just total nonsense. It prints G, O minus, no problem, but then it hits the 3 bytes for she and tries to print each one as if it were its own character, and you get this garbled mess. This is probably the most common beginner mistake in Go, so burn this into your memory. This whole byte and rune thing is also why you can't just change a character in a Go string. Remember, they're immutable. So if you need to actually modify a string, you have to do this little 3-step dance. First, you convert the string into a slice of runes, which you can change. Second, you make whatever changes you need to the slice. And third, you convert that slice back into a new string. Now look, while it's super important to know how to do all this manually, the truth is you shouldn't have to very often.
Before you ever start writing your own string manipulation logic, your first stop should always be Go's awesome built-in strings package. It's fast, it's heavily tested, and it's going to save you so much time. I mean, here's just a few of the greatest hits. You've got split and join, which are perfect for breaking strings apart and putting them back together. Contains, has prefix, these are your bread and butter for searching. Knowing these functions isn't just about writing less code. It signals to an interviewer that you know how to use the standard library and don't try to reinvent the wheel for no reason. Okay, we've got the fundamentals down. Now it's time to level up. Let's talk about the senior level stuff. These are the tricky questions about performance and memory that interviewers love to ask to separate the junior developers from the senior ones. So here's a classic one. An interviewer asks you, how do you get the number of characters in a string? We already know len is the wrong answer. So what's the right way? And here's the important part, how fast is it? And here is the gotcha they're looking for, the performance difference. Getting the byte length with len of s is what we call an O1, or constant time operation. It's basically instant because that number is already stored with the string. But counting the runes with UTF-8.rune count in string, that's an O of n, or linear time operation. That means Go has to walk through the entire string, from beginning to end, to count the characters. On a really big string, that can actually be a pretty slow operation. Here's another really subtle trap. In Go, creating a substring is lightning fast. And the reason why is because it doesn't actually copy any data. It just creates a new small string header that points to the same underlying memory as the original big string. Now that's efficient, but it can hide a really nasty memory leak. Imagine this. You load a massive 1 GB log file into a single string. Then you just take out a tiny 10-byte substring from it. Here's the problem. That tiny substring is still holding a reference to the entire 1 GB block of memory, so the garbage collector can never clean it up. The modern solution for this, thankfully, is super easy. You just use strings.clone. It makes a fresh copy of just the data you need, breaking that link to the giant original string so it can finally be freed. All right, one last senior level question for you. An interviewer asks, what happens when you convert a string to a byte slice, like square bracket byte s? Does that create a copy, or does it share the memory like a substring does? The correct and definitive answer is yes, it always makes a full copy of the data. And the reason for this goes right to the heart of Go's design. Strings, as we know, are immutable. They can't be changed. But byte slices are mutable. You can change them all you want. So if they shared memory, you could change the byte slice and whoops, you just illegally changed an immutable string. The copy is there to protect that fundamental guarantee. So, let's wrap this up. Here are the absolute key things to remember for your next interview. 1. A Go string is an immutable slice of bytes. 2. Len gives you the byte count, not the character count. 3. A rune is just Go's word for a character. 4. Always, always, always use for.range to loop over characters in a string. And finally, 5. Remember that things like counting runes and converting strings have a real performance cost. So there you have it. You now understand how Go strings really work, far beyond just the basics. So the only question left is, thinking about the code you're working on right now, what's the first for loop you're going to go back and refactor?